Okay, so before I move on, I want to go ahead and I kind of read this, but I didn't really explain to you what's going on. I need to probably explain this a little bit more. Where it says on the bottom of page 122, there's a blue box about the inverse function there. Okay, it says that the domain D in range R, if that was the original function, the inverse function is going to have a domain that is now R and the range that is D. In other words, the domain and the range get swapped in the inverse function, which might make sense, right? Because you're swapping X's and Y's, right? When you swap X and Y's, obviously the domain and range will be swapped also. So let's see if we can go ahead and see what this means. If I have a function that looks like this, okay, this is a function we already talked about when we were earlier. So this is the exponential function, correct? Y is equal to e to the x. Okay, this is the exponential function, and I draw the inverse function. First of all, if I want to find the inverse function, I have to make sure that it passes the one-to-one test, right? So it passes the horizontal line test. It also passes the vertical line test, okay? So this is a one-to-one function, which means that it's going to have an inverse function, right? So the inverse function, again, I'm going to go ahead and draw and reflect this across the y is equal to x. So it's going to look like this. Okay, so this is going to be my inverse function, okay? Now the domain of the original function, so the original function was this. The domain is what? The domain is all reals, right? And the range is going to be what? Range has to be, it's going to be greater than 0, right? Range is going to look like this. Okay. Now in the inverse function, when I switch the y's and y's and x's, okay, now the domain is what? The domain is all x, all the possible x's, and x now has to be greater than 0. So x is greater than 0. And the range is what? The range is anywhere between negative infinity all the way to positive infinity. So it's all reals. As you can see, these two have been swapped. Okay, so the domain and range get swapped. Okay. And if you wanted to find out what the one-to-one function was, we started with y is equal to e to the x. Now we're going to switch the x's and the y's. So I'm going to get x is equal to e to the y. So I'm going to take the natural log of both sides. I get natural log of e to the y. Now in the logarithm, I can pull the y up here. Natural log of e is equal to 1, so y is equal to natural log of x. Don't worry if you're kind of confused here. We're going to go over this again, okay? So y is equal to natural log of x is the inverse function of y is equal to e to the x. Okay, and as you can see, the domain and the range get swapped here. Okay, all right. Just want to make sure that we touched on that one. Okay, so now let's go ahead and move ahead. We move ahead, find an inverse function graphically, example number 5. So example number 5, I am given a function that looks like this. Okay, actually it's more of a curve here. Okay, and I'm asked to, for here, and I'm now asked to find the inverse function graphically. First of all, let's see if it has an inverse function. In order to have an inverse function, it has to pass the horizontal line test and the vertical line test, and it seems as though it passes both of them. Okay, and again, I'm going to go ahead and draw y is equal to x. Now I'm going to just reflect this across, so it looks like I'm going to go like this. Like this, and I'm going to be over here, like that. So it's a reflection across this guy right here, right? Okay, so that's how I would draw this graphically, okay? Flip the page, go to page 124. In the middle, there is an inverse composition rule. Inverse composition rule. Okay, what that really stating is, this. It is stating that if function f of x and g of x are inverse functions, okay, so if f of gx and g of x are inverse functions, what it's saying is that the composite functions f dot g is going to be x and the g dot f is going to be x also. Okay, so this is a way to prove if two functions are inverse, okay? This is a relationship that we will use to do that, okay? So let's go to example number 6. It says, show algebraically that f of x and g of x are inverse functions. Okay, so let's see if we can do this. So f of x here, so for example number 6, I'm given that f of x is equal to x cubed plus 1. G of x is equal to cube root of, where is it? Cube root of x minus 1. So f dot g, right? Wherever x is, I'm going to put this guy into here, right? So I'm going to get cube root of x minus 1 cubed plus 1. So this guy becomes what? This guy becomes x minus 1. Then I have the plus 1 x. That works. What about g dot f? Now, wherever x is in here, I'm going to put this guy into here, right? So I'm going to get cube root of, wherever x is, I'm going to put this guy here, x cubed plus 1. Then I have the minus 1. So the plus minus 1 go away. I get cube root of x to the cube, which indeed is x. So as you can see, the relationship works, okay? Okay, so that's that. So let's go ahead and read the purple box on page 125. And that's just a rehash of what you already know. So please read it and see if it makes sense to you. Are there any questions on that? It says number 1, to find the inverse function, you're going to go ahead and first determine that it's a one-to-one function. See if it passes the vertical and horizontal line test. And then number 2, you're going to swap the x's and y's. And number 3, you're going to solve for the new y. So example number 7. Show that f of x is equal to root of x plus 3 has an inverse function, and find a rule for that. So find the inverse function is what it's asking. Okay, state any restrictions in the domains of f and the inverse function. So let's find, so y is equal to, let's see if it's, first of all, it is an inverse function. It has an inverse function. So if you graph this, you're going to get this, right? Minus 3 here. Okay. So now, does it pass the vertical line test? Looks like it does. Does it pass the horizontal line test? Looks like it does also. So it passes the horizontal and the vertical line test. So therefore, it is a one-to-one function, which means that, yes, it will have an inverse function. So now let's find that. So this is going to be equal to, this was like this. Now I'm going to switch the x's and the y's. I'm going to get right of is equal to x. Now I have to solve for y. So I'm going to go square both sides. Y is equal to x squared minus 3. Okay, now the original function has a domain and a range of what? The domain is what? X has to be greater than 3. I mean, negative 3, I'm sorry. The range has to be greater than this. Y is greater than 0, which means that the new function, this guy, is going to have a domain of this and a range of this. Okay, so let's see if that works. So I'm going to go ahead and draw y. So I go to x, and now I'm going to reflect this guy across. So it's going to start at negative 3, and it's going to look like it's going to go like that, right? Negative 3. So yes, y, indeed, the range has to be greater than negative 3, and x has to be greater than 0, right? Okay, oops, as a matter of fact, let's make it proper, because y can be 0, right? Okay, so that's that, and blah, blah, blah. Okay, yeah, we're good. All right, so we're done for the day. Are there any questions that I can answer?